I feel I've been bombarding you with more and more and more terms. Folks, there's only about a 3 left or so, and then you've got them, okay? So let's take a look at the last couple here in this podcast and then the next. All right. The next one is something I've been kind of hinting at and kind of made mention in the last podcast, but now I really, really want to look at it. It's called the principal angle. Now, what does the principal angle mean? Well, it's based on, again, that spinner. Take a look. If I drew an angle out here, and let's say that this is 30 degrees, and I spun the spinner, and it went around once, twice. So I've gone around twice. So I've gone down 360 degrees, plus another 360 degrees to give me 720 degrees, plus 30 degrees more, and I ended up in the same spot. So if you think about this, this is 750 degrees I've gone around. But really, you end up in the same spot, so who cares if you've gone around 750 degrees? From the starting point, you've only gone 30 degrees. That's all that matters, right? That's what the principal angle means. The principal angle means the smallest, and it has to be positive, coterminal angle, right? Okay, so best way to look at this is start looking at the multiples of the angles. For example, if you're talking degrees, start looking at the multiples of the degrees. So you know that you can rotate over 360. The next one's going to be 720 degrees. The next one after that is going to be 1080. All I'm doing here is I'm adding 360 degrees each time. And what I'm going to do is I'm going to compare all of my degrees now to these multiples and see how they work. Okay. Easy peasy. Now, 265 degrees. Think about where that is. If you draw it, look, there's 90. There's 180. You know that this guy here is 270. So this guy's really close to 270. It's right about there. So I got a question for you. What's the smallest positive coterminal angle? You're looking at it. You haven't gone over 360 degrees, so you don't care. And it is positive, so that's your angle. Huh, well, that was easy enough. But look at this guy. This is 1085. This is where these multiples start coming into play, right here. 360, 720, look at that, 1080. Oh, what does that mean? I've gone over 5 degrees. So guess what? 5 degrees is your smallest positive coterminal angle. That's your principal angle. So in other words, this has went around once, twice, 3 times, plus an extra 5 degrees. That's it. Oh, that was easy. Okay, how about the next one then? Oh boy, we're going backwards. All right, so what? If we're going backwards, that means, look, these work the same way. Think about it. 752 means I've gone backwards at least 2 rotations to 720. So I've gone back. So this one's 752. There's 360. There's 720. Plus how much more? If that's 720, look what I've got left. If you think about what I have left, I have a total of 32 degrees left. Right? I have 32 degrees left. That's all I've got. So if you think about this, and that should be a negative, of course, I only went negative from my starting point. I've only gone a negative 32 degrees. But wait a second. Read what this says. It has to be the positive angle. So my question then is what is it from here all the way to here then? Oh, that's easy to do. Take the 360 degrees. I know 360 degrees would be all the way over, so bring me back. Bring me back 32 degrees. Okay, easy. That's going to be 8. 3 from 5 now is 2. And look at that. That's 328 degrees positively here. That's how you do those ones. Oh, those become easy, don't they? What happens when I throw radians at you now? Oh, same. Watch. Start thinking of this now in terms of 2 pi. But again, like I said before, always convert it to whatever the denominator is, right? So 2 pi now becomes, in terms of over 4, becomes, guess what? Yeah, 8 pi over 4, which is also over 6 would be 12 pi over 6. Over 3 would be, of course, 6 pi over 3. Every one of these guys is actually equal to 2 pi, but it's easier to look at them as common denominators, right? Right. Okay, so look at the first one. This is minus 3/4 pi. Well, what does that mean? Look at your nice little circle. If you think about this now, we're going from here. Now think 3/4 pi. 3/4 pi. Well, there's pi right there. 3/4 pi would be right here. There's minus 3/4 pi. You're 3/4 of the way there. Okay, so I got a question for you. Then what's left? Think about quarters. Think about quarters. If you're starting here, right, you want to go to here. Well, all the way around is 8 pi over 4. Take away the 3/4 pi that you have going back now, gives you what's left of a positive angle. So 8 pi over 4 minus the 3 pi over 4 works out to be 5 pi over 4. Oh, wow, no kidding. Well, yeah, there it is. That's simple. Okay, but look at it. If we didn't have these common denominators, we'd be in a whole heap of trouble, wouldn't we? Okay, so let's look at the next one. If you look at the next one now, which says 13 pi over 6, okay, we're dealing with over 6. So there's over, well, look what this just said. Look, you're at 13 pi over 6. You know 2 rotations, or I should say 1 rotation, a complete rotation of the spinner, plus how much more? Think about it. This is 13 pi over 6 minus 12 pi over 6 leaves you with the smallest positive angle, pi over 6, which is somewhere about there. Oh, this is so easy. My goodness. Look at the last one then. The last one then is, of course, pi over 3. And you do have a negative up front, so watch out for that. Pi over 3, right there. You got it. Now, how are we going to do this? Well, think about this. We have minus 22 pi over 3. Okay? We're going by increments of 6 pi. So just keep adding 6 pi to this. Now, you can sit there and go 6 pi more, plus 6 pi more, pi over 3 more, plus 6 pi over 3 more, plus 6 pi over 3. And it can keep going here. Well, if you do this, watch what happens. Plus 6 pi over 3. It becomes a little bit monotonous, doesn't it? This ends up being, okay, equal to minus 12 pi. What am I talking about? Minus 16 pi, yikes, over 3, plus 6 pi over 3 again. This is going to give you minus 10 pi over 3. We're getting close. Add 6 pi over 3 to this again. Woo! Look at this. And all we're doing is adding multiples. 1, 2, 3 multiples. That means it's gone around at least 3 times so far, but we're still, look, in the negative. This is going to give us minus 4 pi over 3. So guess what? Add another 6 pi to this over 3, and look what you finally have, the smallest positive value, which of course is going to be 2 pi over 3. There's our answer. Oh my goodness, that ends up being a real pain in the butt now, doesn't it? Okay, but it works. So, couple things that we have to remember. The principal angle will always have a measure between 0 and 360 degrees or 0 radians to 2 pi radians. That's the principal angle, okay? And it always has to be positive. But what happens when an angle lands right on an axis? Well, one more term for you to memorize. It's called a quadrantial angle. What do I mean? Well, think about this. Isn't this splitting things into 4s, 4 quadrants? So if you land on here, or land on here, or land on here, or here on one of the dividing lines, this is called a quadrantial angle. Okay, all right. So what are the quadrantial angles? You know what they are in terms of degrees. Yep, 0 degrees, 90, 180, right? 270, 360, yeah, whatever. But how about in terms of radians? How does that work? Let me show you how it works. It's really cool. It's setting us up for something called the unit circle. I'm going to show you how that works right away. Watch this. Okay, So if you know this is 0 radians, you know that this is pi radians, you know that this is 2 pi radians. Watch this. If you go halfway from here to here, right? Okay, aren't you going half of pi? Yeah, that's pi over 2. Now, if you keep this in terms of a common denominator, it makes so much more sense. So if we go from here to here now, aren't we going 1 pi over 2, 2 pi over 2, which cancels out to give you pi, right? But what if we go one more over? Well, pi over 2, 2 pi over 2, look at that. That would be 3 pi over 2. And you're probably saying, no, that won't work. Want to bet? Watch this. Go one more pi over 2 over, and look at that. You end up with 4 pi over 2, which equals to 2 pi. It does work. Of course it works, because it's a circle. You're always going to go spinning round and round until you get back to your original.